Oink. Oh, hello everybody. Welcome back for another amazing video. Woohoo! Doink, 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 doink. Oh, hey guys, look, it's Scott. Hi, Scott. Oh, hi guys. My name is Scott. Never would have guessed. And today, we're going to be reviewing about not only how to find the surface area of a rectangular prism, but also how to find the surface area of pretty much any prism with flat faces, with 5 or more different surfaces. A prism with 5 surfaces is known as a triangular pyramid because it has 3 lateral faces and 2 triangular bases. 3 plus 2 is 5, obviously. So, we will be reviewing how to find the surface area of any prism with 5 or more different surfaces. And it's actually very fun. It may be easier than you think. There are a lot of complicated formulas, but we are going to shorten them so that it doesn't become too complicated for you. Remember how we previously reviewed and introduced prisms to you? Yes, we learned that prisms are solid shapes and that they have 2 congruent and parallel faces at the ends called the bases that are usually on the top and bottom, but could also be on the front and back or the left and right. It just matters in congruency and whether or not they are parallel. Is this right? Oh, hey guys, look! It's Puzzle Penguin! Hi, Puzzle Penguin! Oh, hi guys. Just a sec. I'm very busy here. What are you doing? I am inventing some shipping boxes and I'm trying to find the surface area of one of them. The surface area. Interesting. Can you describe the shape of the box? Why, certainly. My box is a rectangular prism that is 12 inches long, 6 inches wide, and 10 inches tall. But I don't know if my answer is correct or not. What is your answer? What did you end up with? I ended up with 444 square inches. Is my answer correct? Well, we previously learned how to find the surface area of a rectangular prism. If you didn't, that's okay. You could just go to our rectangular prisms, square prisms, and cubes video where we introduce prisms for the first time. You could go to that video to reintroduce yourself to surface area, where we find the area of not one, but all of the faces of a prism at once. So the surface area is the area of all of the faces of a prism. Not just one face, not just 2 faces. It's all of the faces of a prism. Oh, well, yeah. Okay, so am I correct? Let's see. Well, you did tell us that the box was 12 inches long, correct? Yeah. It was also 6 inches wide and 10 inches tall. Wait a second. Length, width, and height. We have to substitute width, length, and height into the formula. Did you, Puzzle Penguin? Yes, but I don't know if I used them correctly. Well, for one thing, the surface area of a rectangular prism must be this formula. A equals 2 times WL plus HL plus HW. That is the surface area of a right rectangular prism because it has a 90-degree angle. That's why it's a right prism. Any rectangular prism that does not have a right angle is known as an oblique rectangular prism, where it's slightly bent. So, yeah, the surface area of a right rectangular prism is 2 times WL plus HL plus HW. There's 2 on the left, be careful. We have to multiply WL plus HL plus HW all at once by 2. So there's 2 at the left, indicating that we multiply this by 2. So let's substitute W, L, and H. W stands for the width, or how wide something is. Let's look in this picture. 6 inches seems like the width. Would you look at that? W seems small as well. So the width really is 6 inches. And if we look here, the height is 10 inches. So let's substitute 10. And then the length is 12 inches. So let's substitute 12 for that. It looks like we have an answer 60 greater than Puzzled Penguin's answer. 504 square inches. 504? I thought it was 444. Yes, and if we subtract the two numbers together, your answer, Puzzled Penguin, is technically 60 less than the actual answer. Oh, not again. It's okay, we make mistakes. Byron's right. And those grow our brain, and we learn from those mistakes so that we know what not to do. Oh, thank you, guys. How do I do it again? That's a very great question. You could put the W's, H's, and L's in any order, but all that matters is 1 W, 1 H, 1 H, 1 L, and 1 W, and 1 L. Because there are really 2 W's, 2 H's, and 2 L's in there. So, yes, because a rectangular prism has 6 faces. So you pretty much need to have 2 W's, 2 H's, and 2 L's in the formula. And multiply all of those by 2. So let's get to work. 6 times 12 is 72. 10 times 12 is 120. 120 plus 72 is 192. And 10 times 6 is 60. And 192 times 60, not times 60, plus 60 is 252. And if we multiply 252 by 2, we should get 504. So we should get 504 as our answer. So Puzzled Penguin, the surface area is 504 square inches. Oh yeah, 504. Because I used the formula wrong. Yes. How did you do your formula? Well, simple. I did like you said. A equals 2 times W squared plus H squared plus L squared. Interesting. Let's try that. Imagine we actually put the same numbers in. What do you notice is different? 6 times 6 is 36. 12 times 12 is 144. 1, 2, 3, 4, 5, 6. That is 180. And then 10 times 10 is 100, which makes 280. Then the answer will be different. And then 280 times 2 is 1, 2, 3, 4, 5, 6, 7, 8. 560. Oh my goodness. That's not 444. Oh, then I don't know how I got it. Yes. We just discovered, sorry to make a mistake on purpose, that you don't necessarily do W squared plus L squared plus H squared and multiply that by 2. No. You just do WH plus HL plus WL times 2. So, we're sorry. We made a huge mistake. So the formula is not 2 times W squared plus H squared plus L squared. We just discovered that the answers would be different. Wow! The answers would be different? Yes, because if we multiplied the numbers the wrong way, then it would be the wrong answer. So the surface area is actually 504 square inches. Oh yeah! My answer was too low, 444. It was 60 less than the actual answer. That's right. But just warning you, I have another shipping box. Really? Another one? Yes. I am very busy. Hold on, let me just get it. I'm sure I have it around here somewhere. Aha! There we go. This is the other shipping box I have. Can you describe the shape of that shipping box? Why, certainly. The shape of this shipping box is a triangular prism because it has two triangular bases. Well, at least he knew that. I mean, duh. It is a prism after all. Yes, you're right, duh. And I thought that the surface area of this shipping box is 240 square inches. Is my answer correct? Wait a second. We did not learn how to find the surface area of a triangular prism. Don't worry, I got the formula right over here, Byron. It's as easy as a piece of... Huh? A equals question mark. That doesn't make sense. Oh, I get it now. It's a puzzle. A puzzle? Yes. We have to fill in missing values for A, B, C, and H in order to find out what the surface area formula is. So, let's erase these numbers because they were already filled in by me because I was experimenting with those to see if it actually worked, and it did. So, A, B, and C. Sides A, B, and C are the three sides of the triangle. You know how you trace a triangle? This is always the first line you're tracing, the second line, and the third line. The first line that you trace when you're trying to draw a triangle could be thought of as side A, the second side B, and the third and last as side C. Side A is 5 inches, so let's put 5 for base side A. Then, base side B, which is this line, is 6 inches long. So, let's put 6 over here. And then, side C could be thought of side A, but its reflection. Do you see these two diagonal lines? They look like reflections. They look like they're sitting in an invisible mirror. An invisible mirror. Whoa, excuse me, that's a tongue twister. They look like they're sitting on a mirror. And if you look, they are almost completely identical reflections. And plus, this is congruent to this. So guess what? Sides A and C are completely equal. Side C is also 5. So let's put 5. Let's see. Let's double check to see if we got the correct numbers in, because sometimes we need it to be exactly precise. 5 for side A, 6 for side B, and 5 for side C. Yep, we're all good. But what about the height? Well, let's look at the height of this prism. Wait a second. The H is located on one of the edges of the prism. So H is the height of the prism. That's it. We just need to tilt this triangular prism upside down to see if it matches up. And yes, it does. So the height of the triangular prism is 12 inches. Not 4 inches. Be careful. 4 inches is only the height of one of the triangular bases. So be careful. The height of the prism overall is 12 inches because we see that this makes a straight edge and this makes a straight edge. So we could say that this is 12. My golly, it looks like this time Puzzled Penguin got an answer that's too big. It looks like that the surface area is 216 square inches. Puzzled Penguin? Again? If we subtract Puzzled Penguin's answer from the actual answer, we could see 1, 2, 3, 4, 5, 6. Puzzled Penguin's answer is 24 more than the actual answer. Excuse me. I'm sorry. So, anyways, sorry, Puzzle Penguin, but this time you had an answer that's too large. Oh, I'm wrong again. Yeah, who knows? So, yes. Basically, Puzzled Penguin has an answer that is 24 greater than the actual answer. So, yep. Sorry, Puzzled Penguin. No, it's okay. But how do you find the surface area of a triangular prism? Ooh, that's a very, very good question. And if you want to see the actual equation, it may trip you far and far away. Why? The actual formula is a lot more complicated than simply just the height and the width or the length or something. No, it's a lot more difficult than that. How much more difficult? Get ready to be amazed. The triangular prism has one of the most complex surface area formulas on the entire planet. The surface area for a triangular prism, are you ready for this? Because I'm ready for this, is AH plus BH plus CH plus 1/2 times the square root of negative A to the power of 4 plus 2 times AB to the power of 2 plus 2 times AC to the power of 2 minus B to the power of 4 plus 2 times BC to the power of 2 minus C to the power of 4. Sorry. That got me all tangled up. What is it again? I could say it again, but it's a little struggling. This is one of the most complex surface area formulas that was ever proposed. One of the most complicated. And I could tell you, this is already complicated enough. But we could make things turn out simpler. Instead of just using this long and complex formula, which simplifies to 216 based on precise mathematical calculations, we could instead find the area of each face and add all the areas together. So Puzzle Penguin, another way you could do it is to find the areas of all of the faces and add them together. So pretty much for any prism with 5 surfaces or more, you just have to find the area of all of the faces and add them all together. So let's find the area of the 2 triangular bases. Okay, let's get thinking. So if 5 inches over here is 5 inches over there, then this triangle must be equal to this one. So guess what? The base area of the triangular prism is exactly the same for both triangles because both triangles are equal. So guess what? The areas of both of the triangles are exactly identical. But how do we find the area of a triangle? Well, if you remembered our geometry video about triangles, in which you didn't, then just click the geometry video on our math playlist. Finding the area of a triangle is very simple. You just do half times BH. But what's side B? Side B was 6. And the height is 4 inches because that is only the height of one of the triangular bases and not the height of the prism. Be careful. If you multiply 6 by the height of the prism, which is 12, then you will just find the area of the rectangle instead of the triangle. So 4 inches is the height of one of the triangular bases. So the area of a triangle, pretty much any triangle really, is half times BH. B is 6, H is 4. Let's do this. 6 times 4 is 24. And if we do a little bit of math, half of 24 is 12. So the area of this triangle is 12, which means that the area of this triangle over here, the hidden one, must also be 12, because like I said, the areas are both exactly identical. So guess what? If we add the areas of both of these triangular bases together, we should get 24. But we're obviously not done here because we have to find the areas of the lateral faces and then add those areas together along with the triangular base areas. So let's get right to work. So let's memorize a little bit. The area of the 2 triangular bases is 24. We'll try to remember that in our heads. The area of this lateral face is 12 times 5, which is 60. Okay, memorization covered. 24, 60, which means that this must also be 60, because this 5 inches is congruent to this. So they are both equal, and plus 12 inches is equivalent to 12 inches here. So we could say that this is also 60, and if we add the two 60s together, we get 120. Okay, let's do some math here. Remember, the areas of the two triangular bases are 24 combined. But the area of the lateral faces are 60 plus 60 combined, which is 120. 120 plus 24 is 144. And if we find the area of the final lateral face, which is 6 times 12, or 72, we could add 144 and 72 together to get the total surface area. So let's do some math. 144 plus 72, 1, 2, 3, 4, 5, 6, 7, 1, 2. That is 216. Wow, you just made my problem feel easier. Thank you. It's exactly the exact same answer, because we found the areas of all the faces, and we added all those areas together. So, anyways, for the long way, which is too complicated, the mathematical precise calculations leave us with 216. I don't think that this is the formula we should use. No way. It's too complex, don't worry. Remembering that will need to require lots of skill. And I could tell you, even I pretty much don't understand it either, so don't worry, you're not alone, buddy. This is too complex. I don't think we're going to use this formula ever in our videos. So, but for this time only, in case you want to know, the formula is, and I'm going to say it one last time. Here we go. The actual surface area of a triangular prism is, I love this part, AH plus BH plus CH plus 1/2 times the square root of negative A to the power of 4 plus 2 times AB to the power of 2 plus 2 times AC to the power of 2 minus B to the power of 4 plus 2 times BC to the power of 2 minus C to the power of 4. And that's it. That's all. And if we substituted all the numbers and we went the long and boring way, it would end up with 216. So, Puzzle Penguin, the surface area is 216 square inches. Thank you, everybody. You're welcome. 60 plus 60 is 120. 120 plus 72 is 1, 2, 3, 4, 5, 6, 7. 192. And if we added 192 and 24 together, which is the areas of the triangles combined, then we will get 1, 2, 1, 2, 3, 4. Yes, 216. So, Puzzled Penguin, the surface area of the triangular prism is 216 square inches. Thank you, everybody. Now I could find the surface area of all of these shipping boxes now. Thank you very, very much. You're welcome. See you later. Bye. So basically, the surface area of any prism with 5 or more surfaces and is to basically find the areas of all of the faces and add them all together to get the total surface area. Not with the complex formulas and stuff. Yeah, we're never going to use this. So, guys, trust me, this requires a lot of advanced, abstract, and precise mathematical calculations, which I think is way too complicated for you to start at this age. I could tell you. You may not even know what this is. Yes. So, yeah. Just to be safe and covered. It's better to be safe than sorry. So, we're keeping things safe. We're eliminating this harsh formula with all of these mathematical constants on it, and we're going to set it aside. Instead, we have a simpler formula, thanks to our strategies. Instead of the long and complicated formulas associated with the actual surface area of prisms, we could simply just find the area of all of the faces and then add all of those areas together to get the total surface area. So, there you go, guys. The surface area of any prism with 5 or more surfaces requires finding the area of all of the faces and adding all of those areas together to get the total surface area. So, the triangular prism is the prism with the least amount of surfaces whose faces could be determined as lateral faces, because a cylinder doesn't have a lateral face. It instead has a bent face. A cylinder is a special kind of prism that has 2 circular bases. And although that is absolutely mathematically true, it only has 3 surfaces and not 5. So, when comparing prisms to lateral faces, really, the triangular prism has the least amount of surfaces. However, just like we learned like seconds ago, we know that the cylinder is the prism with the least amount of surfaces because, although its face is not defined as a lateral face, it does have 2 circular bases, which are completely curved and round, and they only have 3 surfaces. But finding the surface area of a cylinder is not as easy because you can't find the area of each face because one face is bent. It's a bent rectangle. So finding the surface area of a cylinder is actually more complicated. But we're going to learn that in another video. So don't worry about the cylinder. Just worry about the flat prisms. Well, not the flat ones. Like, you know what I mean. The 3D solid prisms with the flat, plain faces. And not the bent faces like cylinders have. So basically, we could just find the areas of all the faces and add them all together. Now let's review the surface area of a square prism. Do you remember square prisms? And cubes too? Yes, we went over square prisms and cubes in another video. The surface area of a right square prism is 2a squared plus 4ah, as you could see over here. So, sorry, I have to burp. Excuse me. So the surface area of a square prism is 2a squared plus 4ah. So, yes. And the surface area of a cube is pretty easy. In fact, this prism, which is a cube, I know, cubes are special kinds of prisms. This sort of prism has one of the easiest surface area formulas in the entire world. It's simply just 6a squared. That's it. That's all you have to do. 6a squared. I mean, how hard could that be? You just substitute an edge for a, square it, and then multiply the square of a by 6. How hard could that be? Well, for beginners, it is very complicated, especially if you don't know how to square a number, or if you've never heard of a number raised to the power of 2. 2 is the exponent, but we're going to learn about exponents in another video, so don't panic, don't worry, just learning about the bases of prisms here. The basic understanding of all prisms and how to find the surface area of all of them. So, the surface area of a cube is the easiest, because it only requires one measurement, which is edge, as in a as the edge. So the surface area of a cube is 6a squared. So I don't think that should be too hard for you, especially if you've practiced. But now, we're just getting started. We're going to dive deeper on how to find the surface area of polygonal prisms. That's right. Those are prisms with 2 5-sided bases or even more sided bases. Look at all of these sides. Very complex. Don't worry, I'm going to teach it to you. So, do you know how to find the area of a pentagon? Well, the actual formula is complicated, but if you remember, back in Unit 2, we discovered how to find the area of a pentagon thanks to an extremely easy method which requires splitting triangles together. See? There are 5 isosceles triangles in a regular pentagon, and that is a plane or a flat surface. So if we apply both of these planes for the prism, we could simply split apart the pentagonal bases as triangles as well. Find the area of one of the triangles, and then multiply that by 5 because there are 5 of them. So find the area of one of the isosceles triangles and multiply that by 5 to get the total area of the pentagon. And once you found the area of both pentagons combined, which is by adding the areas together, you next find the area of the lateral faces and then add those together, and then add all the areas of all of the faces together. So it's very simple. That is the same thing for a hexagon. If a prism has 2 hexagonal bases, like a hexagonal prism, you could simply split the hexagons into 6 isosceles triangles, find the area of one of the isosceles triangles, and multiply that by 6. So based on this, we can conclude that an n-sided prism, that is a prism with n sides or an unknown number of sides, is basically just splitting that polygon into isosceles triangles, finding the area of one of the isosceles triangles, and multiplying that by what number of sides that the shape has in the n-gon. The n-gon is a polygon with n sides, an unknown number of sides. So it's basically the area of one of the isosceles triangles times n, or the number of sides that the shape has. So yeah, that's pretty much how to find the surface area of any prism, but only with 5 or more surfaces, because a cylinder has a more complicated surface area and only has 3 surfaces. Again, which I mentioned, we're going to mention in a different video, so don't worry, don't panic. That will actually be on Unit 6. We're on Unit 4 right now. And I'm telling you, Unit 6 is a lot of lessons away, so don't worry. In the meantime, we could still look at the actual formulas, and my, do I tell you, the surface area of all of these prisms is so complicated that they may be more complicated to remember. But they are not as complicated as the triangular prism, thank goodness. They are shorter, but just more advanced. The surface area of a right regular pentagonal prism could also be done the long way, such as 5ah plus 1/2 times the square root of 5 times 5 plus 2 times the square root of 5 times a squared. The surface area of a hexagonal prism could also be measured in the long way, which is 6ah plus 3 times the square root of 3 times a squared. The surface area of a heptagonal prism, or a prism with 2 7-sided bases, is 7ah plus 7/2 a squared times cot times 180 degrees divided by 7. The surface area for an octagonal prism is 8ah plus 4 times 1 plus the square root of 2 times a squared. The surface area of a regular enneagonal prism, or a prism with 2 9-sided bases, is 9ah plus 9/2 a squared times cot times 180 degrees divided by 9. And finally, the surface area of a right regular decagonal prism, or a prism with 2 10-sided bases, is 10ah plus 5a squared times the square root of 5 plus 2 times the square root of 5. So all of these formulas are very complicated, but like I said, remember, split the polygon into isosceles triangles, find the area of one of the isosceles triangles, and multiply that by the number of sides that the polygon base has. Find the areas of those polygons and add them together. Then find the areas of all the lateral faces and add them together. Then find the sum of the areas of the lateral faces and the sum of the areas of the two bases, and add both of these sums together to get the total surface area. So basically what I'm saying here is you could simply add all the areas of all of the faces together to get the total surface area, instead of just following this complex formula. So basically, you just find the area of every single face in the prism and add all of those areas together. That may be a lot of extra work, but at least it is easier than this complex formula. Phew! Although this may be easy enough for me, even this could be a little detrimental about square roots. You will not learn more about square roots, though, until you reach 7th grade, 8th grade, pretty much the junior high grades. So, yeah, in high school, you would have already learned about square roots. But in junior high school, you will get the chance to be introduced to square roots. So all I'm saying here is, I think we'll just stick to the formula that we used with the isosceles triangles instead of this long and complicated formula. Yeah. Thanks for finding the surface area of many prisms with us, and I hope you learned something, because we sure did. Yeah. We sure did. Bye, everyone! See you later in the next video. Bye! Do-do-do-do-do-do-do-do. Ruff, 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 ruff.